Next topic is behavior of conductor in electrostatic field. That is behavior of conductor in electrostatic field. First behavior, what is show? Net electric field inside the interior of conductor is zero. These properties are really very important. So please learn these properties and read this very carefully. First property is net electric field inside a conductor is zero. Now what is the reason behind this? If we place a conductor inside a electric field, so this is a piece of conductor that we have placed inside a conducting field. So we take two plates here, two parallel plates, one with positive and one with negative. So electric field is from positive to negative. So as we place a conductor, we know the conductor, if it's neutral, it doesn't mean that it do not carry any charge. It has positive and negative charge equal. So that positive and negative charge actually start drifting. The negative charge start collecting across the face near the positive charge, and positive charge start accumulating near the face negative charge. So this keep on drifting up to the time when the inside electric field come out to be equals to outside electric field. As this face is acquiring positive, this face is acquiring negative, so internal electric field is in this direction. This is also called polarized electric field. Why so? Because conductor here get polarized. Conductor here get polarized. So that's why it's called polarized field. And it's keep on moving, the charges keep on moving until EP is equals to E naught. E naught is the external field that is here. So when EP and E naught are equal and opposite, so net field come out to be 0. So net field come out to be 0. So that's why net electric field inside a conductor is always 0. Next point. Electric field just outside the charged conductor is perpendicular to the surface. It's just perpendicular to the surface. Why so this? This is because, suppose if we consider this is a conductor, two particle, one is perpendicular, one is tangential. If tangential is possible, suppose if say tangential is possible, means charge start flowing. Charge start flowing in this direction, but charge do not flow, it stay at a point. So means it's always 90 degree. So if theta is equals to 90 degree, cos 90 is 0, suppose electric field is acting an angle other than 90 degree, then there will be component E cos theta along the tangent. This is tangential component. That the surface which tend to accelerate the charge on the surface, leading to the surface current. If this component is there, if tangential component is there, then the charge start moving. If the charge start moving, this mean what? So charge start moving, which means charge starting accelerating and carry surface current, which is not the case. So this means tangential component do not exist. There is only one and one component exists, that is perpendicular, because due to which charge stay at the point where it is accumulated. Next is net charge in the interior of conductor is 0. As it is quite clear, electric field inside the conductor is 0. By using Gauss theorem, phi is equals to E dot ds upon closed integral is equals to Q by epsilon naught. If this term is 0, then complete this is 0. Then Q by epsilon naught equals to 0. This means Q is equals to 0 into epsilon naught, which is again equals to 0. So the charge inside the conductor is again 0. So charge always reside on the surface of the conductor. Charge, next property is charge always reside on the surface of conductor, because whatever the charge we give to the conductor, it always start accumulating on the surface rather than being in the inside. So next is electric potential is constant for entire conductor. Why so? Because we know inside the conductor electric field is 0 and on the surface it is same. So if electric field is 0, then the from E is equals to negative gradient of potential. From that formula we find if this is 0, then potential is constant. So potential is constant everywhere. Next is surface charge distribution may be different at different point. What this mean? If this is a surface the point where the surface has pointed end, it accumulate more charge over there. Because surface density is equals to charge per unit surface. Less the surface, more is the surface charge density. More the surface, less is the surface charge density. If pointed end is present in the uh, in the conductor, then it accumulate more charge. If end is flattened or broadened, then it has minimum charge density. So charge density vary. If surface is small, then charge density is maximum. If surface is more, then charge density is minimum. So this is the important properties of the behavior of a conductor in presence of an electric field.